Now in the next part we have the emulsion. Emulsions are the liquid-liquid colloidal system. Special name is given for the liquid-liquid colloidal system and these are called the emulsion. Okay, and system has to be the heterogeneous because colloidal system is always heterogeneous in nature. So you just do one thing, you try to mix the coconut oil with the water or water in the coconut oil. They never mix up with each other. So do one thing, put that solution on the juicer mixer grinder and try to mix up them. After the mixing you will find out now they are mixed up, but still they not provide the clear solution, they provide the heterogeneous solutions. So my dear friend, that mixture is called the emulsion. That mixture is called the emulsion. It may be the or of the two type. Okay, oil in the water or water in the oil. So we have two type of emulsion system: OW emulsion, that is the oil in the water, or W emulsion, that is the water in oil. Okay, and we know these systems are not very stable. If you leave that mixture after the juicer mixer grinder, then you will find after some time, maybe the 1 hour, maybe the 2 hour, they will separate in the two layer. Okay, because they are not miscible with each other. So these emulsion are not very stable. So to stabilize them, we have to add a third substance, and that third substance is called the emulsifying agent. Okay, let's see. Look, emulsion are the liquid-liquid colloidal system. We have two type of emulsion: oil in water, OW type emulsion. Examples are the milk. In the milk, what we have? In the milk, liquid fat droplet are present in the water. Next example, vanishing cream. Emulsifying agent for this: proteins, gums, and synthetic and natural soaps. Then we have the WO type emulsion, water in the oil. Okay, oil is present in the more amount and water is present in the less amount. That's why it is called water in the oil. Okay, example of this one is the butter. In the butter, what happens? In the butter, inside the fat particle, few amount of the water is also there, or cream. Emulsifying agent for this one is the heavy metal salt of the fatty acid, or long chain alcohol, or lamp black. Okay, emulsion can be diluted by the any amount of the dispersion medium. You want do one thing. Look, milk is the combination of the fat and water. You try to add the milk, you try to add the water in the milk. Okay, it is completely miscible. Any amount of the water you can add in the milk. Okay, in the milk, dispersion medium is the water, and you can add any amount of the water in the milk, but try to mix the oil. Oil is not miscible in the milk. Okay, means what the meaning of this line? You can add any amount of the dispersion medium in the emulsion, but we cannot add the dispersion phase in the emulsion. Okay, next we have the colloid around us. Okay, how many colloids are present in our surrounding? We are surrounded by the so many colloid. First example, blue color of the sky. Okay, blue color of the sky is due to the scattering of the light by the water vapors, by the dust particle and other particle. Those are present in the colloidal range. Okay, they scatter the light in such a way so that it will give a appearance of the blue color. Then next, fog, mist, cloud. What are those? Those are the aerosol. Okay, in the fog, water droplet is suspended in the air and they are present in the colloidal range. So fog, cloud which we see, they are present in the colloidal range. Artificial rain is also the one of the application. Okay, look, cloud is always having some charge. Suppose on my city I have the positive charge cloud. So what I do, I move by the helicopter above the cloud and I spread the electrified sand. What the electrified sand do? It neutralizes the charge of the particle. Then they combine together, they grow in the size and they become a drop, and that drop fall on the earth. That is the rainfall occur, that is called the artificial rain. Then we have the food product like milk, I have already told you, like butter, I have already told you, cream, that may be the ice cream. Okay, milk, butter, ice cream, halwa, fruit juice, etc. These are the food particle, food substance, those are present in the colloidal range. Next, blood. Blood is also the colloidal system. Look, best example we know, if we have some cut, we have some bleeding, what we apply? We apply the alum. What the alum do? Alum coagulate the blood particle on that point. So due to the coagulation of the blood, what happens? We have a solid layer there, so that the more bleeding, no more blood can come out. Next, fertile soil. Fertile soil, okay, is also colloidal in nature, in which the humus act as a protective colloid. Then next one is the formation of the delta at the junction point of two rivers. Look, river A coming from the x direction, it has the positive colloidal impurity. River V is coming from the y direction, it has the negative colloidal impurity. Whenever they meet each other, positive and negative charge neutralize each other. Okay, and whenever they neutralize each other, what happens there? Precipitation occurs there. So due to the precipitation, we have a formation of the delta there. Okay, sometime delta formation you can also see at the sea coast. Then next is the applications, how we can use these application in our day-to-day life or in the industry. First one is the Cottrell precipitator. Look, you must have seen the chimney of the industries. Okay, what is coming out from the chimney? Large amount of the black fumes are coming out from the industrial chimney. Okay, they contain some particle of the dust, some carbon and some sulfide, and these particles are always present in the colloidal range, so they must carry some charge. So what we do in the chimney, in the exhaust system, at the some space we have some electrode. These electrode are either positively charged or they negatively charged. So whenever these, suppose for example carbon black is the negatively charged, and whenever it strike on the positive plate, it will neutralize there, it lose its charge and it will precipitate there. So all the carbon, not all the, but maximum carbon we can remove by these electrode. Time to time we clean these electrode. Okay, what happens due to that? The gases which we pass in the surrounding, they have the less amount of the pollutant like carbon black and dust and the sulfide. Next, you see we have the purification of the drinking water by the alum. This experiment you can do at your home. Take the normal water, okay, and add the powder form of the alum and mix it and leave the water for the some time. After some time you will find some deposition of some impurity at the bottom of the container. What is that? Actually in the water we have the colloidal impurity, and alum will coagulate them, alum will precipitate them. So if we want to, means suppose if nothing is available to us, RO system is not available to us, so what is the method? Cheap and best, you just add the alum. What they do? It coagulate all the colloidal impurity and water become drinkable. Okay, next we have the medicines. Medicines are also present in the colloidal range. Many medicines are present in the colloidal range. They have the large number of particle. Large number of particle means large surface area. Large surface area means better is the reaction. Higher the surface area, higher is the rate of reaction. These particles can be easily absorbed by the body, so they always provide a better way. They always heals, they always treat us better. Okay, many medicines we have. I have given only the two examples here. First one is the colloidal antimony. Colloidal antimony is used for a problem which is called the Kala-Azar. Next one is the milk of magnesia, that used for the stomach disorder. Next, tanning of the leather. Tanning of the leather is also sometimes called hardening of the leather. Look, animal hide, animal skin is made by the positively charged colloidal particle. What we do? On that positively charged skin, we applied the negative charge tanning. Negative charge tannin. So what happens? Precipitation occurs, coagulation occurs. Due to the coagulation, we have the formation of the cross-linking on the surface. So due to these cross-linking, the leather become very hard in nature, and now this leather can be used for the manufacturing of the shoes or the bags. Okay, next, cleaning action of the soap. Look, this we have already discussed in the associated colloid, which was again the application of the properties of the colloid. Next property is the photographic film by the light sensitive AGBR. Look, older photographic film, the film which we use in the older camera, not the digital camera. In that one we have a reel. Okay, in the common language it is called the photo reel. Okay, on that photo reel, what we applied? We applied the colloidal solution of the AGBR. AGBR is light sensitive in nature. As the light at the AGBR, whenever the light fall, it convert into the AG plus half Br2, and after that we can take the photograph by some chemical reaction. Okay, next one is the rubber formed by the coagulation of the latex negatively charged particle. Many rubber plant we have, they release some white color milk. That milk is the OW type emulsion, oil in water type emulsion. Rubber particles are present in the milk. So what we do? We boil it, we leave that substance for the some time. What happens? All the white material will be settled down and they leave the clear layer of the water above it. Okay, we collect these white particles. What is that? That is called the latex. Latex particles are the negatively charged by the coagulation. Okay, we collect these latex particles, and these latex particles we use further for the rubber formation. Okay, then paints, inks, cement, synthetic plastic, and many other chemicals in our surrounding are the example of the colloidal system. And this is the last point of the chapter. I hope that you have enjoyed this chapter and you must understood something good from this chapter. Okay, so at the last, I again wish you a very best of luck on my behalf and on the behalf of the respected entire Chaitanya family for your good luck. So now, good luck and best wishes for your examination. Thank you.